Dear students, in the last video lecture, I have discussed about how a given linear and non-linear equation can be solved in the Excel. In this video lecture, I will discuss how the same problem can be solved in the Python. Prior to going to the Python, I will teach something missing element which I discussed in the last video lecture. I will recollect what we discussed in the last class. So we have two equations. One is the linear equation. This equation can be rearranged. There is a minus equal to 0, 0. So that equation I have solved in the Excel, and that is through the goal sheet. And we also generated data for x and y. These data belongs to the equation which we have here. That is the previous equation. Equal to r, that is, let me take this is the equation v2, and that's what we done it here, that is 2x plus 3. We generated and we plotted the graph, and if you look at that equation very closely here our solution is 2. Okay, and you can observe here the value of my y is equal to 7 approximately when value is 2. Similarly, if you zoom it here, this is the value where at what value of x the y value becomes 0 is called a solution of the given equation which is given here. And since it is a first order equation, we have only one solution. Okay, we also solved a second order equation, also we can call them as a non-linear equation. Yeah, that is x square plus 3x minus 4, and we reframed that equation, that is equal to 0. Generally this is called as f of x. Since it is a second order differential equation, we have two solutions. How that two solutions can be observed in the graphical way is, and just zoom this equation belongs to the second order polynomial equation, and this is the x data and y data. The same thing is plotted here, and if you zoom it here, my graph intersect at x-axis when x equal to 1. So that is the solution we obtained in the previous case. But unfortunately we missed the term, the another solution, where if you look at very closely here, the parabolic also intersect at x equal to minus 4. We missed that term because I'll redo it again. So this is our equation. Let me go to the data set, what if analysis, go to the goal sheet, and I want to the value of 0, that is our function, we have it here. Just look at here, this is our function, it should be equal to 0. And by changing the cell, this I want to change this value, and set the cell should be my E2. Yeah, it is selected. You click OK. Let me start from, it is 8. Let me do it again. What if analysis. Here my initial condition is 8. Just closely observe here, and go see. I want to set this cell and the value of 0 by changing cell of this value. Click OK. Yeah, I am getting solution at near 1. Okay, and if you want to make it as 0, again the same thing, we can follow that. Right click, format cell, and numbers, you can reduce the decimals into 0 and get the value of 0. And the previous case, since I started my assumption value at 8, it moved in the upward direction, reached here 1. Okay, let me redo it the same trick by having different starting value. Let me assume it is a minus 10. Okay, let me start from here. Okay, then again I'll do it again. I'll go to the what if analysis, goal seek, and this cell value that should be equal to 0 by changing my D2. Yeah, just look at here. Now the solution is converged to the minus 4. That is the thing we need to consider while solving the order of equation more than 1. So I'm getting where I'm starting is the key factor here. Suppose I started here, my nearest solution is a minus 4. Suppose I started here, my nearest solution will be the 1. So that solution will be first converged. So this is the way we have to find the solution for the anything in the Excel manually. So this is what we have to do it in Excel. But again, I want to go to the Python. Before going to the Python, what we have done is first we have generated data, that is I given x value from minus 10, 9, minus 8, and I just extended till 10. Then I generated y value through the formula. Then I double clicked on the square so that the formula will be extended to the all the x values. Then I plotted. While plotting this graph, I took, if you remember, I took insert and I went to the chart. One thing is I took this straight line, scatter with the straight lines and make markers. So the markers means the points. Okay, and similarly for this graph, I went with the scatter. This one I went for the straight line. This one I went with the scatter with the smooth lines. Okay, that are the two kind of graph I plotted. How understand this concept? How the same thing can be applied in Python? To do the Python, go to the start button and type Jupyter notebook. For that, you have to install the Anaconda software. For that, I'll be sharing the how we can install Anaconda in the Google Classroom. You can refer that to install the Jupyter notebook or Anaconda, where Anaconda contains the Jupyter notebook. Open. It is opening. Yeah, it is opening the Chrome extension. Now, and just come to the new one. So I am just selecting new Python 3. A Python environment will be created. Now, here in this line we can create a code, and this one is the plus symbol, meaning that if I'm going to click on the plus, I'll create next cell, and this to cut, and to copy the code, I'll copy the cell, and to paste, and to run the respective cell, I can click on this play button, or if you don't want to use that key, I can type shift enter to run the code, and this is to stop the code, and this to reset the entire kernels. And suppose next line I want to write something like, suppose I just type like this, and if you're going to give shift enter, I will get error. Suppose I don't want, I won't type right, I want to teach. Like that I want to pass the information to the user to understand what I'm doing here. For that, you no need to have the code line. For that, just select Markdown, and just this will disappear, and you can shift enter. There will be no error be thrown in front of us. Okay, that is the purpose of these icons. Now let us solve the problem. Okay, let me delete this one by looking at here. Okay, and let me start. Firstly, prior to start, I must introduce you some basic terminology in the Python. First thing is the print function, the basic function. Type print within a bracket. Whenever I want to use a string that is consists of characters, give double quotation hello world. Notice that whenever I am using the string within the double quotation, there is space. We no need to worry about the space. Okay. Now shift enter will get output as a hello world. Okay. Now the same thing I can do. I can assign a value to a. So a equal to 5 and enter b equal to 6. Shift enter. The value for a is stored as a 5 and b is 6. Now I want to add both the term. Whatever mathematical manipulation you can do it. A plus b. Now we no need to give the double quotation since it is not a character, it is a variable. Okay, and shift enter, I will get the value of 11. Same as 5 plus 6. Shift enter, so we will get the 11 values. That is the purpose of print function. Then the Python sometimes will import library. If you look at in the Excel sheet, while plotting the graph or to find the solution, okay, to find the solution, we used goal seek to converge the solution. Okay, and to plot the graph, we went for the scatter. Under that, we selected which function I want. Similar to that, the Python have the different library. I will just show you demo. For a simple example, I want to find the square root of. I want to find the square root of the 64. Okay, what you will do? You will do some mathematical multiplication, factorial, whatever thing to find the value of square root. That is 8. We know that. But in the Matlab, in the Python, we have the library that is called as NumPy library. To import that library, I need to import import NumPy. That is the library I am going to use to solve this problem. NumPy as NP and shift enter. That library will be imported. Okay. The moment I imported, I can find the square root of the value, that is 64 NP sqrt and 64. Close the bracket. Shift enter again. I got the value of 8. That is the purpose of library we are using in the Python. Similarly, suppose I want to plot the graph. So for that, the specific library, one of the library, Matplotlib. That is, I'll import Matplotlib.pyplot as PLT. Okay. The purpose of as PLT is every time I want to use the NumPy, I can't type NumPy.sqrt. These are called as alias. Okay. So next time, whenever I want to use this NumPy library, I just call NP as a nickname for the library. I can import whatever thing I want. Okay. So the moment it is very hard to type entire code whenever I want this to be executed. So I will use PLT to need PLT for import whatever library I want from the Matplotlib library. Okay. That is the purpose. Okay. Shift enter. Next time, now let me consider I have x value equal to let me open a square bracket, that kind of operation called as a list. Okay, let me have, I want to plot a graph between 2, 4, 6. Okay, and this is my x value. Then my y value, let me have a simple straight line equation, that is, let me again open 2, let me write 4, 4, 8, 12. Okay, now I want to plot these data in the graph. Okay, shift enter, these values, I missed comma here. Shift enter here. Yeah, now just use PLT. I don't want to write entire thing matplotlib.pyplot again. PLT dot I want to draw a straight line, P lat and x comma y. Shift enter. Okay, that is the pattern obtained. Okay, suppose I want to label it something linear. Okay, label, okay, equal to linear equation. Okay, again shift enter, and it is not labeled again. Just look at here, to display that linear equation, what have to do is PLT legend. Okay, just open and close parentheses, shift enter. I can observe that it is labeled as linear equation. Okay, like that we can use the different functions of the Matplotlib library to utilize those things. Similarly, what I can do is PLT x label. I want to name it as a x axis. Close the bracket again. PLT dot x label. Y value. Let me give y itself. Close. Yeah. Sorry, y label. Yeah. Shift enter. I'll get the value like this. Okay. So y, and I can name the what is the x and y axis through the code. Same thing we done in the Excel, different way. Okay. Suppose I want to draw a line, a horizontal line in this graph. What I can do is again PLT x h. Yeah, let me check the code again. Yeah, H line. Where I want to draw a line, yeah, I want to draw a horizontal line. Let me consider at 6. Okay, it is a whatever value I am feeding is a 6. 6 is the position of the y. Okay, so you can observe that I have drawn a horizontal line. Suppose I want to change the color. Okay, the color equal to red. Shift enter again. Let me check what is the color code here again. Yeah, red. Okay, let me give red. Yeah, let me give the black. Let me check it again. Sorry, I misplaced that. That should be here. Here the color should be color. That should be equal to red. Okay, let me check it again. Yeah, I have red line. Suppose I want to change the style of that horizontal line. The same thing can be applicable for this line also. Okay, let me put style is equal to, yeah, I want double dash. Okay, shift enter. Yeah, I made a mistake again. That is, the syntax is line state. Sorry, yeah, line state. Shift enter. You get a dash lines. Okay, that is the way we can do a modification in the graph in whatever way we want. Okay, now let us solve the problem, which we done it in the Excel. Okay, for that let me start a new code. Yeah, let me open a new notebook, a Jupyter notebook. First thing I want to import. Okay, I can name them as Okay, first I want to import library, import NumPy as NP. Okay, then I want Matplotlib, matplotlib.pyplot as PLT. Okay, I imported necessary libraries as PLT. Yeah. So I done that. Next thing is, sorry, again I missed a term. Yeah, now it is done. Next thing is, what we next done is, we have after importing library in Excel, what we done is, we are first exploring what could be the possible solution. Okay, to make you understand, first thing in the MATLAB or NumPy library, let me mark down. Suppose my equation is here. Okay, let me take equation which we run it in the let me take this equation. This is our equation, that is equal to 0. Next thing, we to take a coefficient. Okay, coefficient means the coefficient of the x square value. Let me write within the list. Okay, the coefficient of x square is 1. Okay, comma, the coefficient of the x is 3, and the coefficient of the number is a 4, minus 4. I took only the coefficient. Close a list. Okay, so we have to take the coefficient and I have to give the these input to the NumPy library, that is called as np dot roots. Okay, let me create another line for the code execution. Let me type first the coefficient equal to 1, 3, 4. Okay, then enter again. Now I am going to utilize NP library, that is a NumPy library, np dot roots. Okay, roots, and give these values as an input. You can straight away you can give that value as a list, but you can name them, and I can give the name to the within that parentheses. Okay, shift enter. Yeah, that is the solution for that. Okay, yeah, I made a mistake. That should be minus 4 here. So minus 4, again minus 4, shift enter. Yeah, the solution is minus 4 and 1. That's what we observed in the Excel also. The solutions are 1 and minus 4. Okay, now next thing what we done is, we have generated data. Before generating data, let me go to the linear equation also. Now let me take another coefficient. Yeah, let me take here. The value should be, we have only 2 coefficients here. Let me take that value from the manual which we have for the lab. Yeah, here the coefficients are 2, bring this value here, 2 minus 3, minus 7, sorry, we can 0, we will get the value of around minus 4. Okay, so now my coefficient will be 2, minus 4. Okay, and again I want to find the, here let me give the solution as roots. Okay, and here let me assign a variable root equal to np dot roots o f. Okay, and let me execute this line again. And let me check the root. Is it 2? That's what we have it in the Excel also. Same thing I have done it in the Python. So now next duty is I want to plot a graph. I want to decorate the plot also. Okay, let me do it with let me play it with the first non-linear equation. Then let me extend to the linear equation also. Okay, now I want to plot. Okay, plot, and before the plot, I must generate data first. For that, let me do something manipulation. I am going to again use the NumPy library. I'll show you that is called lin space. Okay, let me have x equal to np dot lin space. Okay, opening bracket, starting value, let me take -10, n value is 10, number of data needed is, let me have 20. Shift enter, you can check what is the thing you have done. Okay, x, you can check it generated data starting from -10 and ending value is at 10, and if you count number of data, that means 20 data. Okay, that is the purpose of lin space, a sub library of the NumPy library. Okay, once I've run it, now I want to generate data for y. So y, what is the y? Y is nothing but, as per our equation, this is what our y, or sometimes we will take f of x. Okay, what is the value? X square. The Python, the square is given by double star 2. Okay, then to avoid the mistake, let me close this bracket also. Okay, plus 3 multiplied by again x. So I am just giving this x value here, minus 4. Okay, now let me run it again. Yeah, I have run the values. Now simply you can check for y also. So the corresponding y value also generated here. Okay, next thing, let me do one by one. Now I want to plot that x and y. Okay, plt dot plot. Okay, plot plot x and y. So x and y. Now I plotted the graph. Now I want to have labeled as a non-linear equation. Label equal to non-linear equation. Okay, yeah, within the double quotation, that entire thing will be considered as a string. Okay, so I want to also give the name as equation also. Okay, let me copy paste the equation here. Let me take that equation which we have done it earlier. Okay, yeah, let me copy entire equation. Let me paste it here. Then to display this, we need to include another code, plt dot x, so legend. Okay, if you give the enter, so the legend should be displayed here. And if you want to give the title also, what I can do is I can give the title here. Let me do one by one. Plt title solving non-linear equation in Python. Okay, shift enter, so the title also displayed here. Okay, and suppose I want to give the x and y label, same thing we done it earlier. So plt dot x label, what I want to give is x, capital X values, and I want to consider it as a string. Okay, so I have to put it down between the double quotation. Similarly, I can name plt y label y So let me display entire equation. Okay, this equation. So y equal to this value, or it is equal to f of x. Yeah. Now shift enter. Yeah, I made a mistake. Yeah, again same mistake. Yeah. Shift enter, and you can check here. The y-axis is given here, then x values are given here, and titles are given here. And if you look at Excel, we had a horizontal line where y equal to 0. At that point, we have two solutions. Both solutions are intersecting with the x-axis horizontal line. Same thing can be repeated here. So what I'm going to do here is PLT, okay, x line. I need to give the position of the y, that is 0, and I want to have the color. Okay, color, line color. Okay, line color equal to, let me give red color. Okay, it is only color. And line state, I want to have here, yeah, red. Okay, I want to have, okay, and I want to label as y equal to 0. Okay, and let me check it. Yeah, I have plotted here again, and you can observe that the another label which is missing here. To show that, we have to use always this line at the end of the entire code. So let me cut that code, paste it again here, shift enter. Now you can see the labels are given for the plot. Okay, let me do another modification. I want to locate the point where I have two solutions. Okay, for that, let me again do that. Now I'll be using the scatter, PLT scatter. Okay, scatter. So I want to locate this point. Okay, value of this is, okay, but first I have to give the x value. Okay, x value we have as a solution. What is that value? We have roots. What is the roots? Again I'll show you here. Roots. Shift enter within the list. Okay, -4 and 1. So that's what that is the value I have given indirectly here. Comma. Then I have to give the y value. My y value will be 0, 0. Okay. Now, comma. Yeah. First, let me execute this code first. Okay. And you can observe here. Again, I made a mistake. Yeah. Let me. Roots, not root. Okay. Shift enter. Yeah, I can absorb this. It is in the blue color. Suppose I want to change the color, I can give as a black also. So let me give as a black. Color equal to black. Let me execute as again. So the color is changed to black, and I want to label them also. Okay, again let me go to the respective code. Label. What should be the naming? Should be, it is the roots. Okay, it is expressed as a root. Suppose I want to display the values also. Okay, how that can be done? Okay, for that is a function string in the Python. Type f. Let me type it here. And roots, these things will be considered as a root. Roots x, that is first root, that is equal to give the number. Okay, give the symbol within that x, sorry, roots the first value. Okay, 0th value. This position is called a 0th value. Okay, I am calling, and I want in the fraction of 2. For that, dot to f. Okay, and again go to the symbol, and again second root, then again roots 1. Again I want in 2 factorial, so 2 fraction 2f. Okay, let me execute. Whether I made any mistake, let me check it again. Okay, so let me check with the manual also. Yeah, this is a single quotation. Yeah, we should be within the single quotation. Single quotation. This should be single quotation. Then this also made a mistake here. Here, that is in the manual, it is mentioned as, yeah, these symbols need to be mentioned here. Okay, so I forgot that, I missed that term. Yeah, now let me execute again. Yeah, again I have not closed that here. Yeah, now let me execute again. Yeah, now you can observe here the roots, the first root minus 4 and the second root is 1. Let me give some standard way of doing the roots f, capital F, root, and second root. Okay, that is where I have plotted the graph. Okay, similarly we can do it for the linear equation also. So I hope you can understand that also, but I can use the same code here. Add extra next code line, and before that I need to generate x and y data. So x equal to x dot np dot lin space, again my starting value, we know that 10, my n value minus 10, and let me have it here 19, our number of data. Okay, and you can check it again. And what is x here? You can check it here. I have 19 data here. Okay, so let me have as usual 20 data, or even if you want, you can have 100 data. Okay, and something I might have missed in the code, and yeah, I discussed almost everything. Yeah, suppose if you want to include grids, okay, I won't have the grids as we have it in the Excel. Okay, what you can do is plt dot grid, and sometimes we need to mention true. By default, that will consider as a true. Okay, and I will get the grids. So some error. Sorry, I have it here. That should be here. Already the values are changed. Okay, let me run it again. To run entire cell, run all cells, and you can check it here. The grids are created. Okay, and you will be having the error in the upcoming cells. Okay, let me correct that also here. What I can do here is next thing is I need to adjust this code according to my linear. Okay, so I'll read it again so that you can understand the logic again. In space again, I need to generate y equal to 2 multiplied by let me use this equation in a different way, not in the way we had it in the Excel. Okay, let me delete this value. So let me use this itself. Let me use the same way. So let me use this equation. Let me make it a 0. So I want to find. Let me take this f of x. Okay, and 2 multiplied by x plus 3. Okay, and plus 3. Plus 3. Now let me shift enter, and y and x values are generated again. So now I'll be modifying the code accordingly here. So x and y values are generated again, and here that should be 2x plus 3. And it is a linear equation. Title is linear equation, and x values, y value is again. Let me have this y and again I want a solution at 0, a horizontal line at 0. The color red, everything's okay, but I have to change modification here. Root, I have only one solution here, and respectively I have to give the only one y value. Okay, and here I need to display only one root. Okay, let me remove entire remaining term. Let me check it again. Shift enter. Yeah, it is executing. Yeah, so we have the solution here. Yeah, sorry, it is, we used wrong value. So that is a different value. Let me modify that also here. Here the coefficient are according to our solution here 2 and 3. So 2 and 3. Okay, let me run it entire cell. Run all cells. Okay, let me check it now. Yeah, you can observe here. So you can similarly modify different equation. Either it's a linear or non-linear equation. You can try with the Python code, and we can modify. You can beautify that. Okay. So in upcoming class, in upcoming video lecture, we'll discuss experiment number 2. Thank you for watching the video. Thank you.